Hey everyone, Chang here and welcome to my channel. Now for today's video, I'm going to focus on SAT review, on the most difficult topic, the one that we are super scared of experiencing every time, right? Exponents. Well, actually, no, not really. The one that we're really scared of is logarithms. But since exponents and logarithm are so interrelated, I think it's just a good idea to just go through both of those properties. Now, here's the thing though. Even though I say it's SAT review, it's not necessarily for SAT only, right? You can use it for ACT, you can use it for GRE, you can use it for CBEST, CSAT, any standardized test that requires you to understand exponents and logs. Just use it, right? Because I'm just going over different properties, hopefully not ones that you are just trying to memorize, ones that you know where to derive from. But if you have to, here's where it's gonna be. Right? So first and foremost, because we're all human, and in human nature, we always prefer something easy over something extremely difficult first. So let's go over something easy. Exponents. Right? Well, exponent is fairly simple. Out of all the complex introduction or whatsoever, understand that exponent is nothing more than a number that times itself a certain amount of times. So if we say x to the a power, that's just basically the base, x, right? Times itself, well, you guys can guess it now, right? A number of times. So here's gonna be a number of times based on this exponent a. Plain and simple, that's all exponents are. So we have our properties. Well, the first one, the most common one, is x to the a times x to the b. Well, what is that? Well, based on our understanding of the definition of exponents, that means x times itself a times x times itself b times. Well, you'll have x to the a plus b. Plain and simple, right? And we can keep going. X to the a power divided by x to the b power. And that was a terrible b. There it is. All right, cool. Well, you guys can guess. X to the a minus b. Plain and simple. All right, well, let's keep going. Well, what else? We have our negative exponents. That's 1 over x to the a power is the same as x to the negative a. What else do we know? Well, we also know that x to the a all to the b power is just x to the a b. All right, let's keep going. X to the 0 power is just basically, well, guess what? 1. Only if x itself is not 0, right? 0 to 0 power is not 1. So be very careful of that, right? That could be a potential trick question. I don't think so for a standardized test, but just in case, we should put that there as well. Now, the last thing about exponents that we should be familiar with is that, for example, let's say x to the a power times y to the a power. Basically, it's the idea that we can actually distribute exponents. Well, in this case, that's just x times y to the a power. So this is all the common properties of exponents that you really should know, right? There, of course, are more specialized circumstances, specialized cases and formulas, but if you know this, you're basically good to go with exponents. Now, logarithms. Before we even talk about logarithm, there's one thing that basically relates the two. The idea is that logarithm, log of, let's just say, a to the b equals p. All right, totally made that up. All right, that's the same as if you rewrite it as a to the p equals b. Because guess what? Logarithms are just the inverse of exponents. So if you can remember how these two are related, all of a sudden a lot of these properties are going to look very similar in terms of logarithm. So I'm going to erase all of this and let's just go over the properties of logarithms. Alright, so now let's talk about log. Now log is the one that's super scary. Every time we see it, we're frozen by it because we don't know what to do. Well, here's the thing. Remember that if it's related to exponent, it's actually not that bad. A lot of the properties are going to look very similar to its counterpart in exponents. Well, first and foremost, let's just talk about logarithm. Now, logarithm, you'll probably see it in 3 formats, right? The first one is probably going to be the most common one, log base a of b. Okay, this right here is base. Now, that's where the confusion comes in, right? For logarithm, the base is the smallest number, whereas in exponent, base is the larger number. So do not get those mixed up. Other than that, you're good. Right? So the first one, most common, log base a certain number, a to b, right? Now, the second one is the one that you'll probably see as well. And that can be a little confusing because that's just log without a base. It doesn't say anything and it's going to say b. Okay, what is that? Well, actually, surprisingly, this is one of a very common button in the calculator because guess what? This has a base. It's a hidden base 10. For some reason, we've just decided that 10 is going to be the standard base of logarithm. So we're going to say log base 10, and they would not put 10 because it's just assumed that way. So if you see this in a standardized test or in any like calculators or whatsoever, automatically assume that they're talking about log base 10, right? Now, the next one's even more confusing because it doesn't even use the word log. LNB. This is interesting because guess what? Even though it says LNB, this is called a natural log. The real notation is just log base E, right, to the B. That's all it is, right? And of course, there's this whole topic of E and natural log and how they are the inverse of each other, but I'm not going to go into details because this is just a review and we're just going to focus on the common properties that you need to know so that you can conquer these type of problems. So there it is. There's 3 different ways you will normally see log in any of those standardized tests. Now, what do we know? Well, first and foremost, once again, log is very closely related to exponent. So a lot of the properties are going to be very similar. So for example, let's look at the most common one. Log base A of P times Q. That's equal to log base A of P plus log base A of Q. Oh, okay, look. There might be some similarity or some relation between P and Q, multiplication, and then addition, right? Just like in exponents. So you can guess the next one. Log base A of P over Q, or P divided by Q, right? What is that? Well, log base A of P minus log base A of Q. Plain and simple. I could sort of guess that, right? Well, let's look at another one that maybe doesn't seem all that obvious. Log base A of 1 equals 0. Now, what the heck is that? How the heck would I know that? Right? Remember, in the previous section, before I erased everything, right, I showed you guys how to basically interchange exponents and logarithms. So this is technically a to the 0 power equals 1. That makes complete sense. There it is, right? Let's look at some more. Well, log base A of A equals 1. Which again makes sense if you interchange it and write it as exponents, because that's just going to be a to the first power equals a. That makes sense, right? Now, there are other ones, of course. For example, you can take out exponents inside a logarithm. So what does that mean? Well, let's just say, for example, log base A of p to the x power. Well, that means you can take this guy out here. It's the same as x log base A to the p. Okay, that's one that you should probably know. What else is there? Well, this one is the most important. If you forget everything about logarithm, there is one property that you always have to remember, and that's this one. Log base, let's just say A of P is the same as log base B of P over log base B of A. This right here is called the change of base formula, right? Now, why is it important? Because guess what? When you encounter logarithm problems, most of the time they'll give you a base number that just really doesn't work, especially when you are working with a calculator that is only programmed most of the time to log base 10 or log base E. So, what do? If this, let's just say log base 7, right? A is 7, right? And then P is, I don't know, any number you want. Well, you can't really enter that in the calculator and just solve it. But with this formula, this property right here, the fact that you can change it to any base you want, B, you can choose whatever number you want. you're gonna choose 10 or you're gonna choose E, right? That'll just make your life so much easier. So rather than log base 7 of some P number, it's gonna be log base 10 of P over log base 10 of 7, right? Then you can enter it into a calculator and boom, just like that, it's solved. And there it is. These are the common properties. Now, of course, there are more, right? There's 2 more that you should probably know because they're just an interplay of exponents and logarithm. And since they are inverse function of each other, they technically cancel each other out. The first one is fairly simple. A to the log base A of P is the same as P. Notice that whatever this base right here of the exponent and the base of the logarithm, if they're the same, guess what? They cancel each other out. All of a sudden, whatever you have in here, it's just going to be by itself, right? You have the reverse. You have log base A of A to the P, right? Once again, this guy right here and this guy right here in this technically exponent, right? You can think of it this way. Bringing the P out and log base A of A, we already know is 1. So this right here, you can guess, is just P. Okay, so here's all of your properties of logarithms. All right, so there you have it. You have your exponents, you have your logarithm, you have your properties of each. And then the most or 2 most important things you have to remember is being able to change logarithm to exponents and vice versa, exponents to logarithm. That's the first one. Just remembering the different notation, which one goes where, right? The base goes to the base, this one goes to the exponents, this right here goes to the equal sign, whatever. Just find a way to remember that. The second one, of course, is your change of base formula, right? That's gonna be a lifesaver. Those are the 2 most important. If I had to choose any of them for you to memorize, those are the 2. Everything else, if you can memorize or at least understand where they come from, because if you can understand where they come from, it's a bonus. You'll be able to derive almost every other one of them from that understanding, right? Well, hopefully this helped. Think of it as those super long, very short summary, right? Of formulas that you have to memorize or have to know or be able to use to ace any of those standardized test questions relating to exponents and logarithm. Anyways, thank you for watching this video. If you haven't already, please like, comment, and subscribe. I will see you in the next video.